Today I will give a short component demo of the Wasm-operator component. So Kubernetes operators are a popular way to extend the Kubernetes control plane. The challenge is that they are constantly running processes that use a lot of RAM. So the goal of this component is to reduce the RAM usage of the Kubernetes control planes by running these operators as serverless WebAssembly functions. They shut down when they are unused and start back up when new events need to be processed. So if we look at how Kubernetes works internally, on the left you have a system administrator, and it explains to the cluster what needs to be deployed by creating Kubernetes objects. And then the controllers or the operators, they watch these objects and then they update the system resources. For example, they deploy containers in order to get the cluster into the state that the system administrator requested. These specific objects, they are often described as YAML files. So this is a YAML file that requests the cluster to deploy a container of Nginx and then open the port 80 in this container. Operators are custom controllers that make it possible to add additional Kubernetes object types into the cluster. For example, you could have a Kubernetes object type that adds encrypted virtualized storage, or adds security policies, or adds zero trust communication. We run these operators in WebAssembly as child operators. And then the platform itself also has a parent operator, and the parent operator's only function is to constantly listen for changes in the objects that these child operators are managing. So this component is situated in the management and orchestration layer of our architecture. Specifically, it is the serverless control plane Wasm-operator component. In this demo, it has 3 steps. First, the system administrator creates multiple function objects. Then the operator wakes up and the operator modifies a second cluster object to show how many functions are deployed. In a real-world scenario, the operator would be a little bit more complex and would deploy containers, would deploy these functions either by creating pod objects or by contacting an external system, such as the propeller orchestrator, to then deploy the functions. So let's take a look at the CLI. So the first thing we're going to do is take a look at the resources currently in the cluster. As you can see, there are currently no objects in the cluster because the system administrator has not yet requested anything to have been created. So the first thing we're going to do is deploy a single function. So as you can see, the function is now created. Let's take a quick look at what this function contains. So this is a very basic custom resource with only a single value explaining how many functions are requested. So right now, there is only one function requested. So if we now take a look again at which resources are deployed in the cluster, you will see that function1 object that we just manually created. But now there's also a cluster object created by the operator itself. So if we take a look at the cluster object, then we will see that there is one function running inside of the cluster. If we deploy a couple of more functions in the cluster and then take another look at the cluster object, then we will see that there are now 3 functions running inside of this simulated cluster. What we can also do is we can take a look at the logs of the operator itself in order to see how this works. So it always happens every time a change gets detected, it starts with a new reconciliation loop. Inside of this reconciliation loop, the client, the operator, takes a look at what resources are available in the cluster. And for example, using this function, it also takes a look at the cluster specifically in order to see how many functions are already present in the cluster. Then it increases the number of functions in the cluster from 2 to 3, and then it shuts down again. So that was our demo. The next steps for this component is to integrate predictive weighting into the latest prototype, do an extensive evaluation to show that we meet the requirements of Elastic's KPI 2.6, extend support for also the Go operator SDK, and extend support for other operators contacting other services.